Today we'll see about modes of heat transfer. Basically, there are three modes of heat transfer. First is conduction, second one is convection, and third one is radiation. So conduction is basically taking place in metals. So it is governed by Fourier law of heat conduction. Fourier's law of heat conduction. So what is Fourier law of heat conduction? So it says that the heat transfer rate of heat transfer is directly proportional to the temperature gradient and the surface area of the object. So when we when we do this math, what we'll be getting, Q is directly proportional to delta T dt by dx into area. So when we remove the proportionality constant, we'll be getting Q is equals to K dt by dx. This K is the thermal conductivity. And thermal conductivity of the object, of any object or any material. So which this thermal conductivity, so the rate of heat transfer, amount of heat transfer, how much of heat transfer can takes place is basically based on through conduction is based on these three things. One is thermal conductivity. If we have more thermal conductivity, the object will transfer more amount of heat. If we have low thermal conductivity like insulators and other woods and other plastic materials, so heat will not be transferred. So then the temperature difference is the major player, so which plays a major role in transferring heat. Then the distance through which the material, like the thickness of the material, that will give you the if we have more thickness, the penetration of heat will be reduced. So similarly the surface area, so when we keep on increasing the area, so the heat transfer will be increased. So that is the basic idea behind the Fourier law of heat conduction. So then we have convection. It is convection is governed by which happens between a solid or fluid to fluid. So when we have two fluids passing through each other, so then we the heat will be transferred based on the fluid to fluid heat transfer, or at least one of the fluid has to be traveling. Then there will be, if there is a temperature difference between these two, if there is a heat transfer is taking place, then we call it as a convection heat transfer. So this is governed by Newton's law of cooling. Okay, so what is it basically says Q is directly proportional to surface area and delta T. So let us take some food like idli and dosa. So if we take idli, the transfer, we take the same quantity of batter for both the idli and dosa. But if we take dosa, since the surface area is larger, so the heat transfer will be more. And delta T is the potential, which is the driving potential. So how much the temperature difference, that much the heat transfer. And when we remove if we remove the proportionality constant, we have to introduce a constant which is called as convection, H. So here H is the proportionality constant, which is the what do we call it as heat transfer coefficient. So this is again it depends based on the fluid velocity. So when we when the it depends based on the fluid velocity and nature, like convection can be found out either it is a forced convection or free convection, like that. Similarly, radiation is one of the third mode of heat transfer. Here solid to solid heat transfer, which is neighboring atom gets heated up, like because of the free electron, the conduction is taking place. The fluid flow takes away the heat from the solid surface, or leaving the leaving the heat to the surface. Due to the fluid flow is called as the convection. And if there is no medium, even then the heat is getting transferred, so which we call it as the uh, what radiation. For example, you take sun, which is very far away from earth, so and in between the earth and sun there is no medium, the atmospheric, so air is there for a certain period of amount, like kilometer, so then we don't have anything, so only vacuum is there, even though the wave is getting propagated and it is heating the surface of the earth, we feel the heat. So that radiation, that mode of heat transfer is called as radiation. So thank you.